So, one main thing to remember when you're thinking of writing a hypothesis is definitely it's supposed to help keep you on track, keep you focused as you are designing and setting up your experiment. So you're actually testing what you need to test, and so that you're actually answering that original question. So far, we've had make an observation, ask a question, maybe do a little research, form a hypothesis, do the experiment, right? So before we get to the experiment, we need the procedures. All right, so step number 4, and again, remember the step numbers can actually vary a little bit. It depends on, if how broken down or how specific you're trying to be with those steps. But the procedures are super important. So these are basically just the directions. Right, the directions of how to do. So I will give you a set of directions every time we do a lab. Those are the procedures or what I need you to do step by step. Helps you gather your materials for one thing. I kind of think of it like a recipe. If any of you do any baking or cooking in here, typically you follow a recipe. And so the recipe has the list of ingredients and how much you need. And then it also has the step-by-step instructions on how to do how to make the food or the recipe or the whatever it is you're trying to make. And so not only does it tell you how to do it, but it has that list of ingredients or materials that you need. And so the same thing is kind of true in a lab. When I'm looking to get a lab together or an experiment for you guys, I always have to make sure that I have everything provided for you, or else you're not going to be able to do it. Right? The more precise and detailed, the better. Okay? This is something that in your head, if you understand it, that's great. But if somebody else is trying to do exactly what you're wanting them to do, you have to be very explicit and clear in what you're telling them to do and how to do it. All right? So a lot of times my instructions will be like a front and a back page. You'll be like, whoa, and none of it's hard. It's just like, this is the way I need you to do it so that you're going to get the results that I intend for you to get or hope for you to get. It needs to be so detailed that you could have somebody repeat the experiment, another person could do it, another person could do it. You could have hundreds of people do it, and they should all be doing it the exact same way because your directions are clear enough. They need to be in sequenced order. What do I mean by sequenced? I mean like all sparkly, like a sequenced gown. Sarah?
By the order that it's supposed to be in.
Yeah, like number 1, do this. Number 2, do this. A sequential order, like starting here, working your way down, finishing here. Good. Okay, so years ago, this group actually just graduated last year. And when they were in 8th grade, we did a little project at the end of the year. And they were able to decide if they want to do a Mythbuster Science Fair project or if they want to do this mutated tic-tac-toe thing. So some of the people who decided to do the Mythbuster Science Fair, they had an idea from like a little prompt, and then from there they designed an experiment. This was the person's procedures. This was him telling me how to do his experiment. So first, get all equipment out, your cooling substances. What I'm using, bread, water, milk, and lime juice, measuring cups for liquids, dry substance cup to put bread in, eat the pepper out and cut a centimeter off. If it is really hot, pepper. If not a hot pepper, ½ inch for every substance tested. Do it. Good luck. Can you follow that?
Yes.
What was he testing? Any idea, like what his experiment was about, maybe, Zach?
The hotness of peppers, or what cools down, what soothes the spiciness of the pepper most.
Okay, yeah, and it actually was the substance that helps cool. So at least you kind of know what he's testing. Yikes. Maybe, I guess he's doing water, milk, bread, lime juice. Is that good? No. And first of all, it's It's not even a sentence. There's no ending punctuation. There's a capital. One capital. Holy smoly. So, yeah. Is there a comma?
There's a singular after
Oh, yeah.
sentences.
Oh, wonderful. So he got off to a good start, and then he must have just gotten like, whoa. All right. So here's another one. Same year, same 8th grade group. Number 1, get 4 cups all the same shape and size. Get 5 pennies all the same color. Number 2, fill 1 cup with a cup of cola. Number 3, fill 1 cup with a cup of water. Number 4, cover the bottom of 1 cup with dish soap and add a cup of water. Number 5, cover the bottom of 1 cup with phosphate and add 1 cup of water. 6, place 1 penny in each cup and leave 1 penny nearby as a control. 7, keep track of the time that you put the pennies in the cups. 8, leave the pennies for 24 hours, 4 in liquid, 1 dry. 9, after 24 hours, take each penny out of their liquid and carefully dry them off with paper towels. 10, use the paper towels on every penny, including the control penny. Number 11, test to see which penny has shined the most. What do you think I thought about this one? It was beautiful, right? This person was so clear, so detailed. I knew exactly what she intended. You know what she's testing without even reading the question or the hypothesis or anything. This is very doable. I think if I would do this, I wouldn't have a single question of like, hey, do I need to do this, or do I need to have this, or how much of this, right? It's all clear and outlined, okay? Very big difference in these 2 sets of procedures. Okay, so step number 5, perform the experiment. So to me, this is the just do it, the Nike step, right? So now you've done all this planning and organizing and writing the hypothesis, having wonderful procedures, and so this is where we actually start to get to it, right? So we know that an experiment is a planned activity done to help answer a question, test a hypothesis, or support an opinion. And so this is your definition that you've been looking at in your vocab. Always follow the procedures. This is shocking to me, but so many times people would write procedures and they'd even have really well-written procedures, but then they wouldn't exactly follow them. It's like, whoa, what are you doing? Like, that makes no sense. You have all these directions and then you just are totally ignoring them. And I did see that quite a bit too. So you made them, use them, that's why you have them. Oops, sorry. So as you are doing the experiment, and even kind of in that planning phase, you have to make sure that you're also taking into account the variables. And this is our next big part of our scientific method. So a variable is something that can change or influence the results of an experiment. Okay? So variable, something that can change. I want you to look at the word variable. There's kind of 2 parts. We have the vary and we have the able. All right, so we have the variable. What do you see? Yeah, what does the beginning of that word remind you of? V-A-R-I. What does that remind you of, Zach?
Very.
Okay, like V-E-R-Y, like I like you guys very much, or like V-A-R-Y, like a variety of, okay. So there's 2 forms of the word, right? And we're talking about the one that means like that variety or, different options, right? Vary actually means to change. The weather in Ohio varies greatly. All weekend it was gorgeous. Early this morning we have thunderstorms, right? The weather varies greatly. Now, what does the ending of the word remind you of? That word able, A-B-L-E. What does able mean? Xander?
It means that you are allowed to, basically.
Okay, good. You are allowed to, or you can. Something can do something. So if you put those together, a variable is something that can change. And that's exactly what it means in terms of an experiment. Even in math, right, that variable, that unknown, it's that letter that you use to represent for that unknown number that you're trying to solve for. Okay, so if you put them together, now you get can change, something that can change. All right, so the first one is the dependent variable. This is the effect or result that the scientist is looking for in an experiment. It's going to be dependent on the independent variable, and this is usually what's being measured. So this is most of the time like the data you're collecting. So whether it's time, length, shininess of that penny, cooling ability, that's my email popping through, sorry. Cooling ability of the lime juice, the bread, the milk, the water, right? So it's what you're collecting or the data usually that you're gathering. This is really important. You can only have one in each experiment. So you're not going to be collecting multiple things. So I might have like 10 times, but it's all time. I'm not having time, length, mass, like I'm not collecting a bunch of different types of data, right? I'm collecting one type of data, but I might have a bunch of that same type. Okay. Independent variable, this is what the scientist is changing. It causes the change that we see in the dependent variable. So those different liquids that penny was being soaked in, that's what I changed on purpose. The effect is how well it cleaned that penny. So what I changed is the independent variable. And again, you can only change one thing at a time. If you change multiple things, you don't know what causes the effect that you see. And then it's kind of a waste of time. You want to know, and we do this all the time, like with our horses. Like if we have one that's having trouble with something, it's like, well, maybe we should try this, or maybe we try this, or maybe we try this. And so we always want to change like one thing at a time, because if we're changing two things, we're like, oh shoot, was it changing the feed that made this horse seem better? Or was it keeping the horse turned out more so that they're getting more exercise? Like, so when you change too many things, you don't know what's causing the effect, right? So then it's like, oh shoot, do we keep on that other feed? Or do we change how we're turning it out? Like now we don't know what caused the good effect that we're seeing. And that's a problem. Change one thing. So one way to kind of think, I think of the word independent. Like independent, what do you think of when you think of independent? By yourself, right? You can do it. So that's the way I think about this variable. This is the one variable that is like on its own. It's the one making the difference in the experiment. It's the one responsible for the change. It's separate from all the other variables. Okay? Dependent. When you think of the word dependent, what do you think of? Relying on somebody else. You guys are all dependents on an adult to give you shelter, to give you food, to give you clothes, right? So you are dependent on them. You are relying, like Sarah said, on someone else, okay? And so that's the same thing with the dependent variable. The shininess of that penny was dependent on the different materials used to clean it. The Dawn dish soap, the water, the phosphate, right? Those things that that student used in her experiment, okay? And so sometimes if you think about what the word itself kind of means, it helps remind you of which variable you're dealing with, okay? The prefix in means not. So independent means it is not dependent on anything else. It's the one that can stand on its own. It's the independent one. And so sometimes, again, thinking of what the word itself actually means helps you recall which variable you're dealing with. All right, constants. So the dependent and independent, you can only have one of each of those. The constants, these are the things that have to stay the same, right? And so there are going to be many, many, many of them. The more you can identify and that you can say, hey, this has to stay the same, the more accurate and reliable your results are going to end up being. Super important that you pay close attention to all of these. If you would accidentally change something and you didn't mean to, that might be the effect that you see, not the independent variable that caused the effect, but what you accidentally changed because you didn't keep it the same throughout the whole experiment. So if I'm doing an experiment where I'm testing different bouncy balls and I hold them out and I drop them and I want to see which one will be bouncier, right? If one group is just dropping them like you're supposed to and the other group is slamming them down, that's a big difference, right? So you have to be clear in the procedures. Are you just dropping them or are you slamming them and applying your own force to them? All right, so little things that don't seem like that big of a deal can have a huge effect on your outcome. And so you might, one group might be testing one type of bouncy ball and another group testing a different type, and then the group that's throwing theirs down, they're gonna get lots more rebound and bounce from theirs because they're adding force to the ball as it's being thrown down, instead of just releasing it and letting gravity act on it. Okay, so here's my example. I love food, like a lot of us do. And so here is my example. I always get pepperoni pizza, right? Pepperoni is my favorite. And so somebody's like, listen, you've got to try pepperoni, bacon, and banana pepper. And I'm like, okay, well, I like bacon and I like banana pepper, so maybe I will like it. Like, I'll try anything once, right? So I go to Purple Indian, that's where I always get my pizza. And I go there, I get a pepperoni, bacon, and banana pepper pizza. Take it home, I eat it, and I'm like, nope, not for me. Don't like it. I don't know why, because I do like banana peppers and I do like bacon, right? So I back up a little bit, and I'm like, okay, I changed two things at once. Like, I added two toppings, so maybe I back it up, and next time I get just the bacon and pepperoni. And maybe next time I get just the banana pepper and pepperoni. And that way I can try to determine, was it the bacon I didn't like? Was it the banana pepper I didn't like? Or is it just both of them together that I didn't like? So I changed two things at once, and so it wasn't as useful. So the next time I get pepperoni and banana pepper. I like it. That was good. So then the next time I get pizza, I get pepperoni and bacon. I didn't like it. It was too meaty, like it was just like too greasy, too chewy, like I didn't like that. So now I know, because I changed one variable at a time, that I do like having the banana pepper. That was a good addition, but having both of them I did not like. It was the bacon that I didn't like. Okay, so if you change one thing at a time, then you'll know, what's responsible for the effect that I see. So the bacon was what was responsible for what I didn't like in that new pizza topping situation. All right. And so again, if I change too many things at once, I don't know. Also, if I'm not paying good attention and keeping things the same. So here's a big difference. Let's say one of those pizzas, I stay and I eat the pizza there. Well, I love fresh, hot pizza, like right out of the oven. I live like 10-15 minutes from Mount Gilead. So usually by the time I get that pizza home, it's not bad. Like, I have a pizza bag, it stays pretty warm. But I'm used to it being like that temperature by the time I eat it. Let's say for whatever reason, I decide like we're gonna eat the pizza there. And so it comes out fresh, hot out of the oven, and it's like extra delicious. Well, that changed a variable, right? I didn't keep the idea of getting the pizza, driving it home, and then eating it. I changed that. So because I love fresh pizza, like at a restaurant, like without having to take it home first, that might have influenced whether or not I liked those toppings or not. Like, because the pizza itself was just so good because it was so fresh. The other thing, what if we're out of town and I end up getting pizza from like Papa John's or something. Well, maybe it's the Papa John's bacon and banana peppers that I don't like. Maybe the Purple Indian would have been fine. So again, making too many changes can kind of influence or affect the results, right? So I need to keep as many things constant. So that means same pizza place, same like picking it up, taking it home procedure, right? Everything else needs to stay perfectly the same, all right? And so keeping those things constant are gonna help give you more accurate results. Okay, so these were two words that you guys had said seemed the most unfamiliar to you. The control group and the experimental group. That sound right from what you were telling me? Okay, so a control group, it's a pretty simple idea. This is the group that is not being given the independent variable. So in my example, it'd basically be like my original pepperoni pizza. That's the group that didn't get the change. So when I eat a pepperoni pizza, that's the normal, that's the original, that's how I normally get my pizza. All right, and so this gives us the baseline data. So for me, how much I like that pepperoni pizza is what I'm gonna compare the other pizzas to. So I have to have that baseline data. You guys actually collected baseline data the very first time you did your Mad Minute. You might have gotten like 3 or 4 of the vocab. That was your baseline data. That was your starting point. Before you had any 8th grade science knowledge or any scientific method information, that's what you knew. Now, you guys are kind of like my guinea pigs, my experiment. Yes, be afraid, be very afraid. No, you haven't had 8th grade yet, right? So you are in the process. Everything we do from now on, you guys are getting 8th grade science material. So starting this unit, you know, the baseline for your vocabulary was what you knew coming in. Hopefully everything we do will affect that. So our instruction, the practice, all of that is basically what I'm changing. It's what I'm doing to help you learn the material, right? So at the beginning, you guys are like the control group, right? And so that baseline knowledge is kind of where you start. Hold on. Hello. Yes, I'll send him. Does he need his things? Okay, thanks, all right. Aiden, they need you in the office with your things. Okay, so again, this is like the original, the normal. You do not get the change, okay? The experimental group, just in the name, guess what? They're the group getting experimented on. So that pizza with the banana peppers and the bacon, that's the experimental group. That's the group that gets the changed toppings. And so the results we get from the experimental group will be compared to the results you get from the control group. So how well did I like that changed pizza? How well did I like it with the banana peppers and the bacon? Okay. Some experiments, it doesn't make sense to have a control group and an experimental group. Like, you'll just have the experimental group. But if you need a comparison or you need a baseline, then you'll have that control group. And in the procedures that we looked at, that penny that was left dry next to all the cups, that was the control group. Because it didn't get anything done to it. It didn't get water, it didn't get soap, it didn't get the phosphate. And so that was the control group because it did not receive the change. It was just normal. It was the original penny. But again, sometimes it doesn't make sense for the experiment to have that. Okay, so we're going to stop with the notes there. Okay, I want to take a look at this cheat sheet. This cheat sheet is going to be extremely helpful because a lot of times when we're doing a lab throughout the year, I'll have you identify the independent and the dependent variables and maybe like pick 2 constants that need to stay the same. so it's easy to mix them up, I get it, right? So this cheat sheet is gonna be something that you can always use to help you, right? On the back, don't worry, we're gonna get to that exit card later on. But if you have it on the front, and I apologize, I wish yours could be colored because I think it really helps things stand out a little bit. But this is just kind of a nice little organized way where you can quickly look and see some things. So here we have on the sides, the independent variable, dependent variable, and then you see the controlled variables. So here are some of the key things. The independent variable is what you change, okay? It causes the effect that we see in our dependent variable. So it was that banana pepper and bacon that caused my effect or me liking that pizza or not liking that pizza, right? Only one, right? You can only make one change at a time. So by changing the banana peppers and the bacon together, that was a bad move, right? I had to do it independently. I had to first change and add banana pepper, and then I had to change and add the bacon, but I couldn't do it both together because it influenced, and I didn't know, was it the bacon or the banana pepper I didn't like, right? Here's what is really nice. See how all three of these have a question? You can ask yourself that question for any of our little situations, and you should be able to help you identify the variable you're talking about. So in my little pizza experiment, if I say, what is being changed? The toppings, right? That identifies your independent variable, okay? So same thing over here. If you ask yourself, what is being measured? Well, kind of weird, but like how well I liked the pizza, right? So sometimes it's just like on a scale of 1 to 10, or maybe it's the time in an experiment. Maybe it's the shininess of a penny. Maybe it's the spiciness of your mouth, right? For that pepper experiment with the bad procedures that we looked at. So ask yourself, what is being measured? Okay, and that will lead you to the dependent variable. Because the dependent variable is what you're measuring. It's the effect that you see. So how well did I like that pizza? And again, there's only one. Okay, it might be done 2 different times, like how well did I like the banana peppers, and then how well did I like the bacon. So I have two different times of how much I liked something, but it's still the same measurement. How well did I like it? That's what was being measured. And then finally, the controlled variables, they're also called constants. It makes me really frustrated. In science, we have multiple names for the same thing. So a lot of times you'll see constants or you'll see controlled variables. It's the same thing. So I try to show it to you and word it both ways just so you're familiar and you can understand that you might be asked both ways. But controlled variables or constants, it's all the things that are the same, right? They are the constants and you'll have to have many of them, right? So same pizza place, same method of eating it, like taking it home or eating it there, like it'd have to be the same. If you ask yourself, what parts must stay the same? Right? So if you have to identify any of these variables, all you have to do is ask yourself these questions. So if you're trying to find what the dependent variable is, ask this question. If you're trying to find the constants, ask this question, right? And so then your answer will basically be identifying that variable, right? And so that is something that becomes super important and super helpful. These are just kind of like little, if you're a visual person, the independent variable affects the change that we see in the dependent. So changing my toppings had an effect on how well I liked the pizza. And then another visual, the independent variable is what I change. The dependent variable is what I observed, basically what you measure. And then the controlled variables are what I keep the same. So again, some other visuals to try to help give you multiple ways to keep these variables straight. We're gonna end today with a song.